Geometry 16.3, assume a spherical elephant. It's kind of an inside joke. A lot of times in physics, you assume things that are clearly not true, but it makes the calculations easier. And the more difficult you make the assumption, the more accurate it's going to be. But um, a common example is like assume a cow is spherical or assume a snake is the shape of a cylinder. Um, because you normally don't take things into account like wind resistance, spin, temperature, the angle, what the altitude is, and there's a lot of stuff that you don't take account for at first, and you kind of make things more complicated. So like you have a frictionless monkey, a weightless monkey sliding down a frictionless slide. These are all things that like of course don't exist, but we can use a basic model and then we can get more complicated later. So assume a spherical elephant. Assume the elephant is in the shape of a circle. Um, for a sphere with radius r, its volume is 4/3 pi r cubed, and its surface area is 4 pi r squared. So let's model an elephant with a sphere that has radius of 4.5. So what's the volume of the elephant? So the radius is 4.5, and we want to find the volume, and the volume they just told us is 4/3 pi r, which is 4.5 cubed. So I'm just going to throw that all in the calculator, save some time. So we have 4/3 times pi times the radius, which is 4.5, to the third power. And it turns out that we're going to get somewhere about 381.7. What are we in cubic feet? So that's the cubic feet of an elephant. The surface area of an elephant, so the surface area is 4 pi r squared. So it's going to be 4 pi, the radius is 4.5 squared. And same thing, let's just toss that in. We get 4 pi r squared. And put that in the calculator, you get about 254.5. Okay. Um, let's model a snake with a cylinder now. So we have a snake, and here's my snake. It's the shape of a cylinder. Close enough. The length is 3, and the diameter is 0.2. So that means the radius is half of that, which would be 0.1. So if I want the volume is going to be the area of the base. The base is a circle, so pi r squared times the height. So the radius is 0.1 squared times the height, which is 3. Put that in the calculator again. We have pi times the radius squared times the height. So it's about 0.09. And their snakes are really skinny. You can't really fit a lot of volume in there, so that's not that surprising. Last but not least, what is the surface area of the snake? And if I want the surface area, this one's a little clever. The formula for surface area is going to be 2 pi r squared plus 2 pi r h. I'm going to link a video that kind of explains where that formula comes from and how you can come up with that formula yourself. But the main idea is the surface area, there's 2 circles, so there's 2 pi r squareds. And then like the long piece right there, if you were to kind of cut it and stretch it out, it would just make a rectangle where the height is still the height. And so this would be like the height. And if you were to kind of take like this round circular part and open it up, so if you had like a round circle and you just kind of flattened it out, you get this length right here, which would be the distance around the circle, which is circumference, which is 2 pi r. So the area of the square is base times height. So that's where the 2 pi r times height, that's the area of that rectangle, which would, again, add that to the 2 circles, gives us the surface area. Anyways, once we know the formula, just plug it in. Oh, the radius is not 4.5 anymore. It's 0.1 plus 2 pi r, and the height is 3. 3-foot snake. Let's put that in the calculator. We have 2 pi r squared plus 2 pi r times the height. Okay, so that's about 1.95. So surface area is about 1.95. Okay. Now compute the surface area to volume ratio. So how much surface area is there to the volume for each of these animals? Easy enough. The elephant, we're trying to calculate its surface area divided by the volume. The surface area of the elephant was 254.5. And the volume was 381.7. So let's divide those. 254.5 divided by 381.7. So we're getting about we'll call it 0.67. So the ratio of area to volume is less than 1, meaning there's way more volume. There's more volume than surface area. If I wanted to do the same thing for the snake, the surface area to volume ratio, well, the surface area is 1.95. What is it? Square feet, and this was cubic feet, versus the 0.09 cubic feet in volume. And when I divide those, 1.95, divide that by the 0.09, let's call that about 21 point, 1.95, let's call it about 21.7. So what this is saying is the ratio of area to volume of a snake is big. There's a lot of area with not a lot of volume, where the elephant has a lot of volume but not a lot of area. And why is that interesting? Well, how do you think the surface area to volume could affect the biology of a snake and elephant? One aspect of biology is that elephants are warm-blooded. So to maintain a constant body temperature, their bodies need to minimize the surface area. They need to have small surface area through which heat enters or escapes the body. So the less surface area, the less heat can enter or escape the body, and you get that constant temperature. Like us humans, we always like to be like 98.6. Snakes are cold-blooded, so their bodies maximize the surface area in order to absorb the heat from the environment into their skin. So that's why it's important for snakes to have kind of a bigger ratio of surface area to volume.